Alright, welcome. In this video we're going to be recapping CalBC Unit 2, which in my class is all about the derivative rules. Power rule, product rule, quotient rule, chain rule, rules about inverse function derivatives, rules about trig derivatives, exponentials, all that stuff. So what I'm going to do in this video is I'm going to go into each of the lessons specifically and, talk about the rules, give a couple examples, and then at the end I'm going to do kind of like a formula roundup. So let's get to it. All right, so the first lesson was all about the power rule and some other elementary derivative rules, but mostly the power rule. Okay, and just to remind you of that, what we do when we're taking the derivative of a power of x, where x is the base and the number is the exponent, right? This is when we apply the power rule, is we take the power and we swing it around the front, and then we subtract 1 from the power. Okay, so, a good example would be f of x equals x to the 17. I take the derivative and I get f prime of x equals 17x to the 16. Okay, move the power down around the front and then subtract 1 from the power. Okay, now over here, oh, whoops, gave it away. I'm gonna have to rewrite 6 over x to the 5 as a negative power, right? Fractions and then later radicals you see below that. These are things we need to rewrite as a power so we can make use of the power rule. So I'm going to write this as 6x to the negative 5, and then I'm going to apply the power rule, right? I'm going to bring the 6 down, or the negative 5 down around the front to multiply with the 6, and I will get negative 30x to the negative 5 minus 1 is negative 6. Okay? And then h of x, this is a radical. I don't really have a radical rule, right? We just have a power rule. So we're going to write that cube root as a power of x, and that's going to be 4x to the 1/3 power. Okay. Then when I take the derivative using the power rule, I'm going to multiply the 1/3 by 4, and I'm going to subtract 1 from the power. 1/3 minus 1 is like 1/3 minus 3/3 is negative 2/3. Okay, and that's the power rule. But there were a lot of other rules that I showed you, so I'm going to kind of just copy those in real quick. Okay, the ones that I could think of from that first lesson was the derivative of e to the x. E to the x is a special function because it's its own derivative. That's why we care about it. So that would be e to the x. The derivative of log x, that's one we just got to know, that's 1 over x. Okay, the derivative of sine of x is cosine of x. And the derivative of cosine x is negative sine x. And these are all just formulas that we kind of just got to know. Okay, so, you're going to know them eventually, so better start now, right? But I have not seen a huge problem in my classes so far this unit with people just not knowing the rules they're supposed to know. I'm trying to think. Oh, I've got some properties for you. Let me bring those in. All right. Now, these derivative properties are something that, like, at the beginning, when you first learned about a derivative, you would kind of just take them for granted. I think you would just assume they were true, even if I didn't tell you. But the derivative of a sum is going to be the sum of the individual derivatives. So the derivative of f plus g is going to be f prime of x plus g prime of x. And we make use of that property anytime we take the derivative of like a polynomial with more than one term, or two things added together. We just do it without even thinking about it. But then this one, once you learn the product rule, the constant multiple thing is you start to doubt yourself on that. You're like, oh, do I need to be using the product rule? If you're ever wondering if you've got a product and you need to be using the product rule, yes, definitely. Until you convince yourself that the derivative of a number times f of x is going to just be that number times the derivative of f of x, right? If you're having doubts, use the product rule, use the quotient rule. For now, though, I'm just going to say, because this is k is a constant, so k is a real number, then the derivative of k times f of x is going to be k times f prime of x. And then these are, properties that it's not something I want you to just like memorize, it's something I want you to internalize and believe and understand and apply regularly. Okay, so let's do an example. All right, one really common problem type from that lesson was just write the equation of the tangent line. So I figured I'd go back and do one of those. So in order to write the equation of a tangent line to anything, we're going to need a point and a slope. We're going to get the point by plugging into the function, and we get the slope by plugging into the function's derivative. Okay, so I'm going to say, all right, if I can get it moved back in my shot, my point is going to be, all right, x is 0, and I've got a formula for y, so I'm going to use that, e to the 0 plus sine 0 plus 3 times 0 plus 2. Now in this class, I need you to know that e to the 0 is 1, and I need you to know that sine of 0 is equal to 0, right? So we're going to say that's x equals 0 and y is 1 plus 0 plus 0 plus 2. That's going to be a total of 3. And to get the slope, I'm going to take the derivative of y. Okay, so I'll get dy dx. That just means the derivative. That's equal to the derivative of e to the x is e to the x. The derivative of sine x is cosine x. The derivative of 3x is 3. And the derivative of 2 is 0. Okay? So I've got a formula for the slope at any x coordinate, but I don't need the slope at any x coordinate. I need the slope at x equals 0. So I'm going to plug in x equals 0. And that's going to equal e to the 0 plus the cosine of 0 plus 3. Okay, again, we know that e to the 0 is 1. Cosine of 0, that's also 1, and you should know that. And so that's 1 plus 1 is 2, and 3 is going to be 5. Okay, but now that I've got a point, 0, and 3, and I've got a slope 5, I'm ready to write the equation. And the equation is going to be y minus the y coordinate is equal to the slope times x minus the x coordinate. Okay, and we've written ourselves an equation for a tangent line. That's great. Let's move on to the product and quotient rules. Okay, now in the product and quotient rule lesson, we really just focused on product and quotient rule, but we did fold in a few more trig derivatives. So I'm going to give you the product and quotient rules right now. All right, so the product rule, and it seemed like we were pretty solid on these, at least better than last year. So it seems like we're doing good, but it's hard for me to tell until I go and grade you for your response, right? So I'm going to take the derivative of one of them and leave the other one the same. And then I'm going to add in taking the derivative of the other one and leaving the one the same. I didn't leave enough room. Okay, should have known. That takes a while, right? Let's see. How much room do I have over here? Plenty of room. Oh, except I didn't take my fraction bar with me. That's too bad. It's all right, though. Okay, and then the quotient rule is going to be, it starts off with bottom. So it's bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Okay, and I don't recommend you memorize this in terms of like x and y or f and g or anything like that, because as soon as you do that, they're going to ask you about a quotient that's the opposite of the way that you've memorized it, which is going to make it difficult. So I just always start with bottom, talk about it in terms of bottom and top, and that will keep you from making errors. Okay, very common error, first-time calculus student, is getting the top of the quotient rule like mixed up, and that causes your answer to be off by a factor of -1, like by a sign. But it's really just that you misremembered the formula, and so we got to remember that one right. Okay, that's product and quotient rules. I'd say let's just do a quick example. All right, so here we've got a couple that are pretty clearly products and quotients. Okay, anytime you see two things multiplied together, both of them have x in them, and you're taking the derivative of that, you've got to use the product rule. Okay, so I'm going to go over here and I'm going to say, all right, if I want to take the derivative of this thing, then the derivative will be, okay, I'm going to take the derivative of x to the 3 first, and that would be 3x to the 2, and I'll leave log x the same. Then I'll add in, leaving x to the 3 the same, taking the derivative of log x, and we know that's 1 over x. Now, if all you're asked to do is take the derivative and you don't have to simplify because it's not multiple choice or anything, we'd be safe to stop there. But if we needed to match this up to some answer choices or something, we would probably need to, apply a little bit of algebra and say x to the 3rd divided by x, that's just going to be an x to the 2. Okay. And then for our quotient rule example, okay, I'm just going to apply that. That's derivative is bottom, x squared plus 1, times the derivative of the top, that's cosine x, minus the top is sine x. Oh, this is not looking like it's going to fit, so maybe I'll shrink it up a little bit. Yeah, there we go. Minus the top times the derivative of the bottom divided by the bottom squared. Okay. And that is not something that you're going to want to simplify or clean up or anything like that. That's not going to be the way to go. So yeah, that'll be good. Okay, that's an example of product and quotient rule. Oftentimes good product and quotient rule problems, they frequently come with a graph or a table. And I don't think that that's going to be the best use of our time here together. I'm trying to keep this relatively short to keep you, studying the way I want you to study, which is just working problems and checking your answers, and not just watching me do stuff. So I think with product and quotient rule, if you need more practice, you need to go back and look at quiz 2.2. Go take one of the old quizzes, take the new quiz, just some kind of quiz, work the homework problems, go back to the notes book. You know, just if you're having issues with product quotient rule, you just need to do more product quotient rule. Okay. But I don't think I have, oh no, I do have more to add to this. There were some other formulas that we learned that day, so let me just copy those in. The other trig derivatives, okay? And not always get the question, do I have to know these? And the answer is yes, absolutely, you have to know these. And while it's probably not the most likely thing for me to test you on, you know, right now when we're first learning our rules, remembering is the lowest in the taxonomy of questions. Like, it's just trivia, right? And so I want to see if you're able to apply these rules. So, you know, I'm not super likely to ask this question yet, but I am going to ask these questions over the course of the year because they're something that we just have to know. And the derivative of tangent is secant squared x, okay? But if we don't remember this, remember that we can recover these derivative rules by using the quotient rule. Saying tangent is sine over cosine and just doing quotient rule on that. We can recover on these if we don't remember them. Derivative of log x, if you don't remember it, you know, it's a long road to get back there. It's not impossible, but it's a long road. The derivative of secant x is secant x times tangent x. Okay. And then when we go to take the derivative of the cofunction, the derivative becomes the cofunction, just like the derivative of cosine became negative sine, right? It was the cofunction and it became negative. Same thing's going to happen here. So it's going to be cosecant squared x, but negative. And this one will be cosecant x cotangent x, but negative. Okay? And again, you could recover these using quotient rule, or you could prove them for yourself if you didn't believe me using quotient rule and some trig identities. You know, it's right there for you. All right, I was feeling a little bit of doubt about that, and so I went back and looked in at our notes book, and that was all the formulas we learned in 2.2. So let's move on and do some chain rule discussion. All right, 2.3, the chain rule. And I'm telling you, this year we did a lot better than we did on this last year. Okay, but this is always a high hurdle to clear for a first-time calculus student. So if you're sitting there like, I'm pretty good with power rule, product rule, quotient rule, I think I did all right with inverse function derivatives, I'm still struggling on the chain rule. Okay, good. You and everyone else and me when I took calculus for the first time, right? It's one of those things. So I'm just going to give you the chain rule right here that the derivative of f of g of x is we take the derivative of the outside while leaving the inside the same and then multiply by the derivative of the inside. Okay. But I've got this scaffold that I think is very helpful for you when you're taking these, especially when you're first getting started learning it. And I did not make this up. Big credit to Mr. Messner who showed it to me. He's our AB teacher at my school, and that it really has changed the way I instruct chain rule. And I feel like it's more empowering to you, the student, to at least if you're not entirely sure what to go, at least you know the structure of it and you're much closer to the right answer. And I'm finding kids in my class are much more computing chain rule derivatives using this method than just trying to apply the rule or remembering the rule or whatever. Okay, so what we do is we identify the outside and the inside. Okay, I just write O and I, outside and inside. Okay, then we are going to underneath take the derivative of outside and inside. Okay. Now, when I write the outside, and you'll see me do this, I'll do a few examples of this. I'll do one that's regular, I'll do one that's like got 3 layers, I'll do a few things. When we take the derivative of outside, and when we write outside, we're gonna leave the inside blank. Okay, and we take the derivative of the outside and just keep leaving the inside blank. Okay, and then at the end we fill in the blanks. But to find the derivative, the full derivative of outside of inside or whatever is going to be equal to outside prime multiplied by inside prime. And so outside prime, that's f prime, multiplied by inside prime, that's g prime right there. Okay, and you'll see what I'm saying here in a second. All right, so a good preliminary example that's only got kind of like one layer of chain is y equals e to the sine x. I know that oftentimes my students have trouble recognizing chain rule scenarios when there's an exponential, so I always recommend when you're looking at e to the something that involves x and is more than just x, you might throw some parentheses around that if that helps. I don't really know, or just remember that exponentials are very commonly chain rule derivatives, right? As long as it's not e to the x or e to the x plus 1 or something that has a derivative of 1, there's going to be a chain rule implication. Okay, so if I've got e to the sine x and I want to take the derivative of this, I need to identify what's on the outside and what's on the inside. On the outside, I've got the exponential, the e to the whatever. Okay, so I'm going to leave the inside of the outside blank. Okay. And then the inside is going to be that sine x. Okay. So if I take the derivative of outside, I know that the derivative of e to the x is e to the x. So the derivative of e to the whatever is going to remain e to the whatever. And then inside prime, okay, I know the derivative of sine x is cosine x. Okay. And then eventually I know that dy dx is going to equal outside prime multiplied by inside prime. So I'll say that dy dx, ooh, pardon me, that wasn't very nice, is going to look like e to the whatever, that's outside prime, multiplied by inside prime is cosine x. Okay, and what goes on the inside here is the same that went on the inside here at the beginning, which you can see is right there. So I just keep that the same. And the insides, they always stay the same. Okay, so let's do one that has, 3 layers or something. All right, here's a good one, and I'm glad I found this one. I was kind of scanning, hoping to find one that I could, explicitly prepare you for. I didn't really find any that kind of fit the bill of having a triple layer, but I did see one that had, like a power of sine or a power of cosine. And it's like, oh, okay, that's something I need to remind them about, right? That when I see that sine squared, that can be a little tricky, and that's one that we're best off rewriting as well to get to our O's and our I's. Okay, so when we take sine squared, what we're really doing is we're taking sine, so it's sine of x cubed, and then I'm squaring it after the fact. It's just that when I put that square after the x to the 3 or after that second parenthesis, it can be a little unclear. Am I squaring the thing I'm taking the sine of, or am I taking the sine and then squaring? So that's why they forever have put the squared next to the sine, is to indicate that you're taking the second power after the sine. Okay, but for our chain rule purposes, we want to clearly see what's kind of on the outside and on the inside, and that's the way to write it. So I'll go over here and I'll say, all right, my outside is going to be the thing squared. Okay, I've got a middle now, right? That's the sine. So I'm just going to do outside, middle, and inside and multiply all the derivatives together just like I've been doing. Okay, middle is the sine. And the inside is equal to x to the 3. Okay. I'm going to take the derivative of the outside and of the middle and of the inside. And we know that the derivative of something squared is 2 times that thing to the first. The derivative, that was outside prime, the derivative of the middle is the derivative of sine of a thing. And we know that's going to be cosine of a thing. And then the derivative of the inside is equal to 3x squared. So if I need to multiply these all together to dy dx, because I know dy dx is going to be outside prime multiplied by middle prime multiplied by inside prime. And, we could do this with more middles than that, right? We could make this, we could have it make as many layers as we want, really. But I don't think that, hopefully I just want you to internalize the chain rule on one layer and outside, middle, inside kind of situations, and then once you are really good with that, then you'll be able to take the derivative of any kind of chain rule situation. Okay, so over here, dy dx is going to equal 2 times that thing to the first, whatever was getting squared originally, multiplied by cosine of something, then multiplied by 3x squared. I feel like this is where this method really shines. I always had people taking the derivative of the outside and then taking the derivative of the inside as well. And I put out a more challenging triple layer chain rule problem on my quiz this year, just seeing like, hey, is this method working for the kids? And I flipped through the quizzes and they were mostly right. And so that was kind of the validation I needed, that I needed to be teaching chain rule this way. Okay, so outside, okay, what goes on the inside of this squared bracket is what went on the inside of the squared in the first place, so that's sine of x cubed. Okay, what goes on the inside of cosine is what went on the inside of sine originally, which is x cubed. And then, okay, that's it. And I've got myself a derivative. Okay, I feel like this is much more foolproof than the way I used to do it. It was just like, take the derivative of the outside while leaving the inside the same, and then multiply by the derivative of the inside to account for the chain rule. And I'm realizing now that that's like what they told me how to factor, which is like, just look at it until you figure it out. And it's like, that's not very good advice. But, you know, I'm doing better now, and y'all are doing much better. So great work with that. I think that's all I've got to say about the chain rule. Let me look real quick through my notes. Okay, there was one more thing, and I will show it to you here on the same screen, but I think that, you know, I haven't probably given the same amount of time to chain rule as I gave to, you know, the other ones, because I just only did a couple of examples. But this is right there with power rule in terms of like importance. It's something that we're going to use every day for the rest of the year. So, you know, we really need to internalize that. And the other thing that I showed you was just another derivative formula. It was the derivative of a number to the x, okay, not x to a number to the x, where the variable is the exponent. That's going to be kind of like e to the x, except we have to scale it up by the factor of log of a. So a to the x times natural log of a. Okay. And you can show how that's true using the chain rule, but I don't think that's going to be the best use of our time right here. I think that the best thing for me to do is to give you all the rules, collect them all together on the screen at the end of the video, and then just do some examples and, you know, move forward. So let's keep going. Let's go to 2.4. Let's talk about inverse function derivatives. All right, now the last lesson was the derivative of f inverse. And honestly, this is kind of like a built-in review day because this is just a formula. And on your AP exam, this is at most one multiple choice question. This is not like a heavily represented topic. This is actually a very fringe topic. It's one that's easily forgotten about. So don't spend 25% of your practice time practicing derivatives of f inverse. That would not be wise, because much like the AP exam, you're going to see one question on this on your unit test, right? It's going to be mostly product rule, quotient rule, chain rule, power rule, derivative situations, stuff like that, right? Just taking derivatives. All of the questions that you've seen on the notes book, on the homework, on the quizzes, that's what you can expect to see on the test. Okay, but you can expect to see one of these table problems as well. So I'm just going to give you the formula here, and that's the derivative. Actually, I'm not even going to write it like that. I'm going to say f inverse prime equals 1 over f prime of f inverse. And I'm going to remind you that f inverse is just some x value. Because f inverse is not 1 over f of x, it's the type of investigator that it takes in a y coordinate, it takes an f of x value, and it traces back to the x that got you there. And in AP Calculus, we don't have to worry about like domain considerations and all sorts of what ifs and bad things that can happen with inverse functions. It's just always defined and always unique in this class. It's good to be an AP Calculus student, right? Because we don't have to worry about a lot of things. So 1 over f prime of f inverse, let me just copy in a table and give you a very typical problem here. All right, so here's a table of values for a function f and its derivative. And we're just going to say that f is the type of function that has an inverse function everywhere. It's out there, and they ask you something like, what's the slope of the tangent line to the graph of y equals f inverse of x? Slope of tangent to f inverse at x equals, should have already decided this. I think we're going to need that to be -2. Because that's tricky enough, you could be tricked into choosing the wrong column or whatever. Okay, and they're always going to do this where you have -2 in the x and -2 in the y, and it's like, okay, which one am I picking? Am I picking that first column or am I picking the fourth column? Okay, so we got to go back to the formula, right? Remember that we're interested in f inverse prime of -2. Okay, so that's 1 over f prime of f inverse of -2. Okay, first step, find f inverse of -2. Okay, now in order to do that, I'm going to go up here. I'm going to set f of x equals -2. Okay. Oh, look, I found it. Here it is. That's f of x equaling -2. I trace back to x's, that's x equals 1, and that's when I say that f inverse is just some x value. That's what I mean. I'm now taking 1 over f prime of 1, okay, and that's 1 over -2/5. Okay, now, of course, in free response, that would be a good place to stop. But I'm not going to ask you this question in free response. I'm going to ask it to you in multiple choice. So you're going to need to know that 1 over a fraction effectively flips the fraction, and this is going to be negative 5 divided by 2. Okay, that's how the inverse function derivative problems work for College Board AP Calculus. Almost always, it's a table. You backtrack to the x, and then you forward track to the derivative, and then you're going to do 1 over that derivative. Okay, it's a very much a question of like, hey, do you know the formula, and have you done this before? Okay, and fortunately for us, now we've done it before, and we know the formula, so we're good to go. Okay, I think that's all I'm going to say about inverse function derivatives, except we've got that. Okay, obviously the formula in blue, but I'm going to clear out the example and give us just those last 3 formulas that we learned about on the 2.4 day. And those were the arc-trig derivatives, right? The derivatives of arc sine, arc cosine, arc tangent, which are the same as inverse sine, inverse cosine, inverse tangent. Okay? I heard that maybe some of the pre-calc classes didn't use the arc language last year, or didn't write it like that, and that's fine, right? I'm just here to remind you each time it comes up that those are the same things. Okay, these are formulas that we just have to know, although they can be, you could figure out how they're true using like a triangle diagram, and if you're interested in that, I'll work with you on it, or you can just kind of look it up on my channel. I've got these proofs out there. The derivative of arc sine x is 1 over the square root of 1 minus x squared, which seems like the kind of thing that's going to have like major domain issues, but arc sine already has major domain issues, so it's actually the same thing. The derivative of inverse cosine is going to be negative 1. It's going to be the exact same as the derivative of arc sine, just negative. So 1 over the square root of 1 minus x squared, but negative. And then arc tangent, that's the easier one. That's just 1 over 1 plus x squared. Okay, and I think that's all the formulas. And so now let's round them all up together, get them on screen. All right, there they are. Okay, that's the full roundup of all the formulas that you just must know for this unit. Okay, now, like I've said, some of these, are they realistic, or am I really going to ask you about them on the upcoming unit test? Some of them, no, right? But some of them, you can bet on them, right? And I think you should know which ones, based on having talked to me, heard what I've said about it. If you have any questions about this, please don't hesitate to contact me. I'd be happy to answer any questions you got. And if you're still feeling unsure, you're feeling like you need more practice, obviously I'm going to redirect you to the quizzes and stuff. Since you're still around after 27 minutes, I'll tell you that one place that like a couple of free response problems that I've really liked to model my free response problems off of from previous AP exams would be, I believe it's going to be 2016 Calculus AB number 6 and 2017 Calculus AB number 6. Okay, those are both ones that have a table in them. I think 16 was just a table. Now, obviously, we're not going to be able to do anything that has an integral in it. Just find the derivative rule questions and focus on those. And I think 2017, that was one that was like very mixed media. It had like a table and a graph and maybe an algebraically given function. I really liked that one too. And those are a couple of problems that I've been modeling my free response for derivative rules tests off of the past few years. Okay, otherwise, I think that's all I've got for you. Thanks for watching. I really hope this helped. And, like I said, if you are feeling like you are missing something or needing something more as you're studying, as you're practicing these derivative rules, you're just going to contact me. And otherwise, thanks for watching.